this assignment because I'm sure some of you are like stuck. Well, today I am making you unstuck. Hopefully by the end of the day, you should be getting into the 90% survival rate. Yeah, it sounds, I know, tough, but part of your struggles have been on purpose. Okay. A big part of solving any problem is getting into the language or the worldview of the problem, right? You have to immerse yourself in the problem and understand, because otherwise, if I say model.turn I4, out of the gate, you have no idea what I'm talking about, but now you mean directly, now you know I mean directly away from I. Or hopefully you're at that point. If you're not, then that's okay. But let's go ahead and go through that. Also, as we're going through stuff today, you may find that I correct like highly embarrassing errors like extremely quickly. This is because that I have made that error multiple times. It's not because you're dumb. It's because the only way to be able to fix a bunch of errors that you'll encounter is to make them in the first place. Okay. If you don't make these errors in the first place, you won't know how to fix them. So making errors is part of how you'll learn. So just keep that in mind. So let's go ahead and share the screen. So over here, afternoon. So this is what I left you off with, and you went into lab. Awesome. So again, the kind of idea here is that our default move should be just kind of staying put. Now, the reason for this is that the fox has all this complicated code, but all it comes down to is I need to find the fox. The fox needs to find the rabbit. That's what it comes down to. The fox has to find the rabbit. If he can't find the rabbit, can't win. Whereas the rabbit, staying put is pretty good because, again, it looks and then it moves. That's the way it always has to work. It looks, then it decides on what its move is based on the information available. So it can move, then it's my turn, and I'll be able to see him before he sees me, and I can dart out of the way or go where I'm needing to go. So staying put is in general a very good move. So what can we do? Well, if the fox sees me, that's when I need to react. Now, one thing we can do is we can, just to test it out, is that we can decide on a move. Now, obviously, we don't want to move towards the fox. This is the opposite of smart, let's say. This is not a good move, right? That means direct move to I. Now, moving directly away from I is not at least that bad of an idea. Model.turn I, 4, right? That means move directly away from the fox. Oh, yeah. So I'll need to share my entire screen so you'll be able to see everything pop up. I hope you enjoy my extremely original wallpaper, by the way. So here we go. Let's go ahead and run Rabbit Hunt. Okay. So run. And now, no step, just keep going. So now he moves directly away from the fox and dies. Again. Directly away from, oh, no, he couldn't run directly away from the fox. Boop. Yeah. Just basically has he either runs out of room or has nowhere to go. That bush blocked line of sight there. So we're actually this could be a win case for us. Yeah. Staying put, it has its benefits. But yeah. So we can't really run anywhere sometimes. Okay, here we can run, but notice that I crash into a wall. So there's two problems with that. The first is that I run out of space. And the second is that, like, I don't have any other options as to where to go. But let's just kind of look at let's go and zoom back in. Rabbit Hunt afternoon. So let's go ahead. We'll run the grader. I've upped it to 30,000 times. Stop that. run the grader. So moving directly away, well, it works more than 0. That's good. 1% of the time. Works 1% of the time every time. So we've got, so that's not exactly a good move. Where do I get the number 4 from? So remember, the model.turn gives me relative to direction I, how many 45-degree turns am I going to make? So that is 1, so 0, 1, 2 perpendicular, 3, 4 is directly away. So given direction I, 4 gives me directly the gives me exactly the opposite direction. Make sense? So the other thing is that this doesn't break line of sight, right? In part, our strategy, we want to break the fox's line of sight. So what is a number that would break line of sight instead of 4? 2. Okay. Other suggestions, because 2 would break line of sight. 2, 5, 3. Any others?
Anything aside from 0 and 4.
Yep, anything aside from 0 and 4. So let's go ahead and leave out 1 and 7, because 1 is forward towards the fox and to the right, and 7 is forward into the fox to the left. We can come back to them at a different point. Okay. Whereas 2 and 6 are different. 6 is basically, I see the fox, I'm going to sidestep to the left. 2 is sidestep to the right. 5 is back into the left, and 3 is back into the right. So let's go ahead and try those. So we got 2 as a suggestion instead. And we'll see that just by putting in 2, we get a dramatic increase, 13%. Okay, now we'll put in 6, which is to the left. Whoa, 30%. And this isn't just some kind of statistical swing, by the way. Or like, this isn't luck. It's 29% survival rate right there. Versus to go to the left versus going directly to the right. Now, why is this? Well, it's because the fox has a bias in its move. When he tries to go around obstacles, he's going to go to his left first, right? Or sorry, to his right first. And also when he ends in a direction, right? He starts moving, let's see. Can move current direction. When he starts looking for a new direction, he starts looking for a valid direction in a clockwise manner, I believe. So he has kind of, so basically there's a bias. He doesn't alternate the way he moves. He's going in straight. The fox's entire code is, if I haven't seen the rabbit, I'm gonna pace in a straight line. If I can't, and then these two things are for getting around an obstacle like a bush. If I can't navigate around that obstacle because I've hit a wall or something, I'm gonna essentially bounce off of it, choose a different direction to go in and start pacing in that direction instead. So that's why. So because of this behavior, where he's going in straight lines and randomly bouncing off, but determining what he's doing in a clockwise manner, choosing 6 is a bit more advantageous than choosing 2. But what about back? Well, we can go through the numbers, but and I won't bore you with that, but if we check 5, we get all the way up to 36% survival rate just by doing 5. For reference, and you know what, I'll go ahead and do 3. 3 gives you, so the order in which you try things matter. All right. But okay, but that's all well and good, but this is only 36% survival rate. And I'm like, well, 36% survival rate in 1, 2, 3, 4 effective lines of code plus 2 semicolon lines. So, you know, let's go ahead and see what's going on in Rabbit Hunt so that we can, and I'm going to stop share and share screen. Let's go ahead and see what's going on over here to see the rabbit's behavior. Now that it's turning 5, it stepped like that. And notice that the fox is basically completely missing it because it's basically dodging out of the way to get break line of sight. At this distance, that's huge. All right, let's try another one. So eventually, though, they get into a situation where you're trying to back up into a bush. That's what happened there. Let's replay this one where he's going, dodge out of the way, and then back into a, yeah. Okay, so watch what happens. Back up, out of line of sight, out of line of sight. Now he's in line of sight, but he can't move away. Couldn't move away in time because there was a bush to his back and left. Now, had he been able to go back and right, he would have been perfectly able to deal with that. So what can we do? We can ask a question. Yep, exactly. We can ask a question. We can ask, if I only want to go back into the left, if I'm actually able to go back into the left, if can move, which is one of the methods listed on the PDF and in here that an animal can do. Also, you might have seen it in Fox, if can move, which means if I can do this direction, then I'd like to do it. So simply copy, paste, put in the the curly braces because that is the appropriate behavior here. And then I can try other. So if this doesn't work, if this block of code doesn't work, if I cannot move back into the right, sorry, to the left, I can try doing other things. Does that make sense? So to run the program multiple times, you go to the grader. To run the program, you go to the grader. You either to run Rabbit Hunt runs the simulation, grader runs a bunch of those silently in the background. If you for can move, if it's for everything. If it's an invalid space, if it's an invalid space, he can't move there. Can move is pretty straight, is pretty good. It makes sure that, like, hey, if there's a edge or a bush there, I can't move there. If I return a direction that I can't move in, it will stay still. So yeah, so the idea here is to try other directions as well. You want to make sure your rabbit has options. Okay. So everybody kind of understand? Now, I'm sure many of you are furiously typing that all down and trying to make sure that you don't get any errors. That's silly because I've got a chat box right here. Here you go. Take it. Dropped it into chat for you. Your IDE will clean it up for you. No, you can use this as the basis for you, but none of this. That's fine. You can do something else. In fact, I should talk about that something else right now, for which is the kiting. Yep, hiding around it. So let me get a map set up over here so that I can switch the share as well. And I just need to remember I can do new share instead. So step. So let me go ahead and mark the screen. So let's take a look at this bush over here. Okay. If you can get your rabbit next to a bush, right? What you could essentially do is that you can get the fox into an infinite loop. As long as the fox is like right next to you, right? So believe it or not, there is not really any fear to have the fox next to you, because if you know what you're doing, because again, the fox moves at the same rate you do. So long as you can stay a step ahead of it, it can't eat you. So say that we start over here and the fox is over here, right? We could potentially move over here. And the fox could move over here. And then I could move over here and the fox would then follow. So you just simply get, so actually what's going to happen is if you do that, here's what will happen, right? So you're over here, fox is over here. Fox says, this is your last known position. You're now going to break line of sight with the fox by moving here. Okay. Fox is going to look around, says, I don't see him. I'm going to go to his last known position, which is right over here. So he moves here. You're here. You're saying, aha, the fox is there. So my next step is to dodge right over here into this thing over here. Now, here's the interesting thing that you'd think that the fox would move here. But the thing is, he has no idea where you are at this point. The fox has no idea. He's completely lost because he moved to his last position. He's lost you. So now guess what? He's going to choose a now random direction to move in. Basically, if you've got a bush like a solitary bush like this, you can just essentially, in a couple steps, just hide behind the bush. It's pretty funny and effective, but it also requires a bit more code. Now, yeah, you have to find a bush, which can make it tricky. So let's see. The other thing you wanted, so let's talk about other things we need to do. Okay. Now notice that I didn't care about like getting caught in corners or anything like that. If you do the code I used correctly, then you should get up to a 90% survival rate. Okay, that's pretty high. To push it any higher, that's when you start taking into account walls and edges and stuff. Like thinking, okay, I haven't seen the fox for a while, but I'm close to an edge. Should probably move away from that edge. That will get you into the 95% survival rate. To get into the 100% survival rate, which only 2 students have ever done, you have to ignore everything I just said. Because everything I just said was completely irrelevant to the strategy of getting 100%. The people, if you have to think like a complete and utter troll in order to get 100%. So, and a bit of rules lawyering as well. So, next week I will reveal the 100% strategy. So, but for right now, that's what I have. So here's the way this is going to work. I'm going to stop the recording. I'm going to split you up into breakout rooms, or rather you're going to split yourself up into breakout rooms. 7 worked last time. Split yourself up however you decide. Okay. And then I will come room to room. If you've got, and then I'll ask you to share your screen if you've got any issues. Okay. Does anybody have any questions before we split you up? All right. So go ahead and yeet yourself into the appropriate room. I will go in a completely non-random order. All right. Room 1. Let me stop the recording at this point.